Hi, my name is Aaron Poletti. I'm a senior physics undergrad at UC Davis. I'm doing research on heavy ion collisions under Daniel Sebra and Manuel Calderon de la Barca. The question my research is trying to answer is whether traditional particle production models will work for fixed target events. The Monte Carlo Glauber model has been used at the Large Hadron Collider and RHIC. The Glauber model assumes transparent nuclei, which works for higher energies, but this is a problem at lower energies because nucleons become opaque to one another and collide more like billiard balls. The Glauber model generates gold-gold nuclei and simulates binary nucleon-nucleon collisions using three geometric parameters, which are the impact parameter, the number of binary nucleon collisions, and the number of participating nucleons. We then plug these events into a negative binomial distribution to simulate particle production. Our analysis has explored varying the hardness parameter x, which scales the number of times we sample from the negative binomial distribution. Collaborations at CIS18, RHIC, and the LHC use the Glauber model to fit multiplicity distributions. Hades, Phobos, and Alice have used the appropriate x value for very low and very high energies. RHIC traditionally set x to be 11% for energies lower than 200 JeV. Our study has considered how these fits change as we allow x to float. In this study, I've analyzed energies in the fixed target range with the 3D hardness parameter. At 3 JeV, the Glauber model fits the multiplicity curve well, with small deviations in the most peripheral events. You can see the hardness at 3%, which is below RHIC's value. The fit was still good at 7.2 JeV. We found a hardness of 56%, which is higher than the 11% suggested, but the deviation at low multiplicities is larger than the 3 JeV fit. We tried varying hardness over different ranges, but we didn't see any improvement. Zooming in closer to our 7.2 JeV fit, you could see a discrepancy between the data and the Glauber model. So why the inconsistency? In fixed target collisions, trajectories at mid-rapidity travel at angle eta relative to the transverse axis. At the higher end of the fixed target range, eta causes trajectories to miss the outer time projection chamber, so we get incomplete acceptance. This could mean that the Glauber model actually does work at these energies, and the discrepancy is due to missed tracks from the outer time projection chamber. As we've seen, the Glauber model does work for 3 JeV fits with an adjusted hardness. However, the fit isn't as good at 7.2 JeV due to the incomplete acceptance. For our upcoming steps, we have a larger set of energies to scan in the fixed target range, which could help clarify discrepancies and find a relationship between energy and hardness. We can also test fits with a multiplicity-dependent efficiency turned on. Thank you for taking the time to check out my research. I'm looking forward to any questions you might have.